Let's resuspend our primers and then go ahead and QC them to make sure that they are at the concentration that we're expecting. So to resuspend them, you basically, if you've got 25 nanomole, you put 250 of your reagent. Your buffer in this case is just nuclease-free water. And you're going to do this so that you will have the primer concentration at 100 micromolar, a typical concentration that is used. Once you have it at 100 micromolar, you typically want to dilute it down to 10 micromolar because you use primers at a concentration of 0.1 to 1 micromolar. So that you have it at 10 micromolar, it's ready to go into your PCR reactions by doing a further 1 in 10. So here we just do a 1 in 10 and you've got your 10 micromolar, label it, store it. But before we store, we're going to do a QC step. We're going to go to the NanoDrop. It's going to measure how much we have by measuring absorbance at 260 nanometers. It will also measure at 280 nanometers just so it can give you an indication of if it's contaminated with proteins, but it shouldn't be. So your A260 280 ratio should be quite high, close to 2, about 1.8 to 2. And so that's what we're doing here. So at the NanoDrop, you just want to turn it on at the back. Then you're going to put 2 microliters on the pedestal after blanking it. So the blank is just usually whatever reagent you used to resuspend your primers in. In my case, it was nuclease-free water, so the software just needs to know what the background reading is. Then you load your sample, and once you load your sample, it's going to ask you to enter what the sequence. Well, in this case, you're going to enter the sequence of the primer. And once you give it the sequence, this allows it to know what the molecular weight is and factor into it what the concentration is. Our primer concentrations are given to us as nanogram per microliter. And so we need to find out the molecular weight of the primer, because now what we want to do is convert from the amount that we have to micromolar. So in the instance where we have a primer concentration of 90.2 microgram per milliliter, we need to now convert it to gram per liter because we're heading towards concentrations. So our 90.2 microgram per milliliter will become 90.2 divided by 1000, because we would need to convert the microgram to gram amount. So the difference from microgram to gram is we go from microgram, then we're going to milligram, and then we're going to gram. So as you can see, it's actually a million-fold difference. So if we were to do the 90.2 divided by a million, because we want to go to gram, then this is what it becomes. This is the conversion. But then because we were in milliliters and we want to go to liters, we can now multiply by 1000 so that we're showing the results as gram per liter. Next, we want to divide by the molecular weight, because then that's what's going to give us the mole per liter. And so the molecular weight for this primer is 6,209. And you will find this from the certificate of analysis that the primer manufacturer gives you. Now we have to convert to micromolar. And so we're going to multiply by 10 to the 6 or 1 million. The reason why we multiply by 10 to the 6 or 1 million is because when we're going from mole to micromolar, there are actually an in-between scale, which is millimolar. So we would have gone from mole to millimolar, which is 10 to the 3. And then from millimolar to micromolar is another 10 to the 3, which is how we get the 10 to the 6 that we multiply it by. And as you can see, we get 14 micromolar, which is great because we were aiming for 10 micromolar. So we're not too far off.